Hi. Today we're going to study the integral of trigonometric functions. Right. We begin with the following two simple identity, right? And the integral of cosine x dx equals negative sine x plus constant. Okay. Right. No, it's positive. Yeah. Because when you differentiate, you get this, get a cosine x. But when you differentiate cosine x, you get negative sine x. So integral of sine x will be negative cosine x plus constant. Okay. By simple substitution, you can also quickly get the integral cosine kx dx. Okay. All you have to do is just divide the sine kx plus divided by k. Okay, so when you differentiate, k will be canceled out. Okay, and similarly, you will get negative 1 over k cosine kx plus constant. So those are the integral of a you can talk about integral of a tangent x, integral of a cotangent x, right? And the integral of secant x, and the integral of a cosecant x. Those are the functions we usually want to find the integral. Okay, they are not. You can use a substitution maybe to find out the integral. Let's do this. Okay, for example, integral of tangent x, right? Integral of tangent x, and you have to use a substitution because tangent x can be viewed as sine x over cosine x dx, right? So it's natural to use a substitution. You let u to be cosine x, right? Then du equals negative sine x dx. So the integral becomes u sine x dx will be negative du, right? So then will be negative natural log of absolute value u plus constant. Okay. Then you replace it by cosine x. Replace u by cosine x. So that's what I can get. Okay. And similarly, you can find evaluate the integral of a cotangent x. Okay. The integral of cotangent x. Oops. Okay. Integral cotangent x is very similar because this is a cosine x over sine x, right? So use the substitution now. Use substituting that to u to be sine x, and du equals cosine x dx. Okay, so that's just integral 1 du over u. Okay, so the antiderivative is this. Then you replace u by sine x. All right, so that's about the tangent. How about secant x? The secant x, those are the simple functions, right? Yeah, the secant x. Okay, can we quickly get to the antiderivative? No. Okay, it's going to be 1 over cosine x dx. Right? I like sine cosine because I'm familiar with those two functions. Yeah, you cannot memorize so many different formulas for different functions. So when you see the 1 over cosine x, what are you going to do? I think it's pretty difficult, right? So in mathematics, there was a trick here. We always use is you multiply the denominator with the numerator by the same function. Right? Then you probably can use substitution because cosine squared equals 1 minus sine squared. Okay. Okay. So yeah, let's go to all right. All right, yeah. So now use a substitution, right? Then you can, this is difficult. The difficult level is one level higher than the previous problem. So you let u to be sine x. Okay. Not everybody can jump from this step to this step. Okay, or then from there. Okay. So du equals cosine x dx. And that will becomes du over 1 minus u squared. All right. Now this is a formula we are familiar with, right? So the antiderivative of this function is going to be hyperbolic inverse of hyperbolic tangent type x. Okay. Well, you can keep using that, right? But and that is going to be. But I don't like the inverse of a hyperbolic tangent x. So I prefer to use the natural log, okay? Half of the natural log and the 1 plus u over 1 minus u, okay? 1 plus u over 1 minus u, right? Plus constant. Then, yeah, we don't like we prefer, we don't like the inverse. Actually, natural log is also inverse function, but we are more familiar with this function. Okay, so this is answer. Yeah, so natural log is also inverse, but this inverse function, we already know the graph, and it's much easier to understand. So we prefer using natural log. Okay, so similarly, you can do for the cosecant x. If it's cosecant x, 1 over secant x, maybe not. Let's look at it. Okay, I'm not sure. Okay, cosecant x is slightly. Yeah, let's try. Okay. Okay, those are the total how many functions we have, right? So it's going to be sine x dx, right? So the same trick, you multiply the numerator and denominator by sine x. Okay, it's almost similar, right? Right? Then sine x becomes 1 minus cosine square x, right? Then you know what substitution you're going to use. I can let, in order to get the sine x, right, I can let u to be cosine x or negative cosine x, doesn't matter. You can even put a negative sign, cosine x. Then du equals sine x dx, okay? Okay, so this becomes 1 minus u squared du, and you get exactly the same, okay? So then same in function. So that would be u, right? And u is negative cosine x right now. Okay, so we got all the integrals. Yeah, we evaluate the integral of a single function, but in the last class, right, we even tried to find the integral of those inverse function. Okay. Now I'm not going to do here. We only focus on the functions, not the inverse of the functions. All right. So our next problem is going to be the integral of sine square x dx. Okay. All right. So how do we solve this type of problems? We cannot apply the formula directly, right? we know the antiderivative of sine x. We don't know antiderivative of sine square x. So you have to use some formulas. So this is a formula we use very often. Cosine x is going to be cosine square x minus sine square x. Now, if you want to keep a cosine square only, there's 2 cosine square minus 1. There will be also 1 minus 2 sine square x. Okay. So if you use this identity, and then you will get 1 minus cosine 2x divided by 2. Okay. Then you can, what is changed is that you change the square to just without square, right? To something without square. So it will be 1/2 minus 1/2 of cosine 2x dx. So this is a subtraction of 2 functions. So the first one, antiderivative is half of x. The second one, how do you get the cosine 2x, right? You have to sine 2x, but you have to divide by 2 in order to get sine 2x when you differentiate. Okay, so plus constant, that's it. So this is a function. And this is the antiderivative of the original function. Okay. Now, if you don't like a double angle, then you can write it like a sine x and cosine x. Okay, plus constant. Here's another formula. Sine 2x is going to be 2 sine x cosine x. Okay. Yeah, sometimes we use this formula. Okay. So we solve the cube, right? How about we solve the sine square x? So, cosine square x will be similar. Okay, I'm not going to do that here. I just only work on along the sine line. Okay, sine x. All right. So think about how can you deal with the sine x, sine cube x. Okay, the idea is that we should know cosine square x plus sine square x equals 1. So that means sine x is always can be converted to 1 minus cosine square x. Okay. So this is a formula we use already when we integrate cosecant x, right? Integral cosecant x. All right. So this is also a trick. Okay, you separate. Sine cube x is sine x times sine square x. Okay. Sine square x is going to be 1 minus cosine square x and sine x. The next step is apply you use a substitution. Okay, it's pretty similar to the problem integral of 1 over sine x. Yeah. Right. Yeah, we already did this integral 1 of sine x to the negative power, right? Yeah, right. That's what we did. This, yes, right. We did this. Then this sine x is a denominator. Okay. So you let u to be cosine x. Okay. Then du will be negative sine x dx. Okay. Right. So it will be integral 1 minus u square sine x dx will be negative du. Okay. So you get the integral of a polynomial. So you get u square minus 1. Okay, then you know how to find the antiderivative, right? So this will be 1/3 u cubed minus u plus constant. Then you replace u by cosine x. Right. right? So look at this, right? So the difficult part is this: you have to separate sine cubed to sine x, sine square x, right? Yeah, see, sine cube x is going to be sine x and sine square x. Okay, and then 1 over sine x is should be equal to sine x over sine square x. You see, we create sine square x. Yeah. Here we multiply numerator, the numerator denominator by sine x. This is a very standard technique we should know. Okay. Okay. All right. All right. So now you will ask, is there any other method you can solve this problem? Well, the answer is yes. Okay. If you can you can get another solution to evaluate the integral. You can use a substitution. You can use the integration by parts, but I don't want to do that because it's a little more complicated. Okay. Yeah, it's not a unique method. So I'm going to take a look at the sine to the fourth power. Just increase the power. Let's see if we can keep solving the problem. Okay. Now, how can I do that? Because it's to the fourth power, right? It's too high. Well, then the trick is this is going to be sine square x n square. Well, everybody knows that, right? But because the sine square, then you get 1 minus cosine 2x square, right? Then actually the power is decreased, right? It's going to be 4, 1 minus 2 cosine 2x plus cosine square 2x. You see, step by step, right? So it's going to be a quarter minus 1/2 sine 2x. That's okay. How about the cosine square 2x? Cosine square 2x is half of, I think it's 1 over 8. It's 1 plus cosine 2x. 2x is 4x. Okay, so you get all the terms without the squares. Okay, so let's simplify a little bit. 1/4 plus 1/8 is going to be 3 over 8 plus cosine 4x. Okay, so this is a function we are going to deal with. Okay, so you know how to find the antiderivative of each term, right? The first term is 3 over 8x. The second term, I have to divide by 2, so it's sine 2x divided by 4. This one I have to divide by 4, so 32, I think, right? And the sine 4x. Because 4 times 8 is 32, plus constant. So this is the answer. Okay. This is the answer. If you can express in different form, like sine 2x must be written sine x times cosine x, that's fine. Multiply 2, right? But that's good enough, okay? Yeah, the point is you have to express sine to the fourth power as a combination of a single a function without power, okay? So then you can evaluate the integral. Okay. Okay, so let's see. Let's continue. And I want to continue to increase the power. Okay. All right. So sine to the fifth x. I think the key point is this is turns out to be not that difficult. Okay, and as long as it's other power, I can always express in the form sine to the fourth power sine x. Okay, right? So what is the next step? You think about. Okay, I give you a little bit of time to think about, to try. I hope you get the same idea as I do. Okay, let's try. I hope you already figured out how to do it, right? It seems to me we have to use a substitution to get sine x dx, right? So how about the sine to the fourth power? Well, sine to the fourth power, remember, is sine square x squared. But this time, I'm not going to use a double angle. I'm going to use a 1 minus cosine square x. Okay, so it's going to be 1 minus cosine square x and square and sine x dx. So the substitution should be equal to, yeah, u equals sine x, cosine x, then du equals negative sine x dx. Okay. Yes. Right. So it's going to be 1 minus u square and negative du. Okay. And anyway, this is a polynomial. The polynomial, you can always expand it, right? And you get 1 minus 2u squared u to the fourth power negative du. So I'm going to rewrite it in the form negative 1 plus 2u squared minus u to the fourth power du. Right. Then you find the antiderivative for each of the function. Right. So you will get negative u plus 2 over 3 u cubed plus 1/5 u to the fifth. Right. So that's it. And what is our substitution here? Cosine x, right? So you replace u by cosine x. Right. So that's and then you can continue if you want, you know, like a sine to the sixth power, but I'm not going to work on this right now. Okay. Yeah. Okay. Sine to the sixth power 6. okay, will be yeah, you can evaluate, but it's just a little bit more complicated. So now next one is, so I don't need to work on cosine only, okay, cosine function only, because similarly, yeah, one can evaluate integral of a cosine square x dx, cosine cube x dx, cosine to the fourth power dx, and sorry, and cosine to the fifth. Okay, now for practice, maybe you can try this, okay, at home. So what I'm doing, what I'm trying to do is a mixture, right? The mixture of two functions. Yeah, mixed type. So the first they can mix up with sine x cosine x dx. This is easy, right? You just yeah, if two functions are involved, sine and cosine. So you can there are a couple ways to do it. One is you change it to sine 2x dx. Then the antiderivative sine 2x is going to be negative cosine 2x, but you have to divide by 2. Right? You have to divide by 2. Okay. But you can also use a substitution to get the same answer. Okay. Similar answer, okay, differ by constant. So here, let's see, it's negative a quarter cosine 2x plus c. So if another student want to solve the problem using different ideas, for example, you can let u to be sine x, right? Then du equals cosine x dx. Then this integral is going to be, this part is du, right? This part is u. So it's u du, right? Then the answer will be half of u squared plus c, and what is u? U is sine squared x plus. So it seems to be you are getting the different answers, okay? But this c is not that c. So all I need is to check, do they equal or differ by constant, right? Right? So we get two different answers, but the computer can tell whether those are the same answers or two, okay? I can check. So sometimes the answer is not unique. It depends on how you approach the problem, okay? Now, if I get a quiz, I find out all the steps are the same, even the comma, then I have a reason to suspect that you're cheating, working together, okay? Do you agree, right? Because different people have a different style to write, even sign your name, okay? So even solve the problem step by step. You cannot say I have the same tutor. That's why I have the same idea. Even same idea, the expression will be different. Some people prefer write u equals sine x, then change the line, du equals cosine x dx, blah, blah, right? So so that's why how the detective trying to figure out who is the suspect, to find out. Yeah, they can always find some small difference. Yeah. Okay. So anyway, so different people have different answers, different solutions. Okay, the answer could be the same. Okay, but the way you write, probably different people are different. Okay. All right. So those two are the same. Why it's the same? Let me check. Okay, quart cosine 2x is going to be 1 quart. Cosine is going to be 1 minus 2 sine squared x, right? Cosine 2x. So it's going to be negative quarter plus 2/4 is 1/2. Okay, so they only differ by a constant. That's why they're essentially the same answer. Right? So my next problem, I have to increase the power. Okay, I increase the sine square x, cosine x dx, but doesn't matter what power you're going to put there. You can put any power, right? Sine kx. Then you just use a substitution. Okay, so k is not going to be -1. Okay, that's all we need. Okay. Then the natural substitution is u equals sine x. Okay. Then the du, right? So du, it's the same idea, right? Du equals cosine x dx. So it's going to be u to k's power and the du. Okay. Now why do I have to assume k is not going to be -1? It's because if k is -1, it will be different. Antiderivative, right? You have to use the natural log. When k is equal to -1, that is the product is going to be cotangent x. Right? The u is a sine x, the k plus 1 and plus constant, right? All right. So the most interesting case is when sine x and cosine x are the same. That both are yeah, sorry. Yeah. Right. Thank you. Yeah. So you have two possible ways to start with, like substitution, begin with substitution, or trying to reduce the power, right? Because we don't like the square here, right? Square is always, if you see a square, I think substitution does not work at the very beginning, right? So how can I reduce the power? Which formula can we be using? Well, still we have the two formulas, right? Cosine 2x equals 1 minus 2 sine square x, right? So sine square x can be converted to cosine 2x. Another one is sine 2x equals 2 sine x cosine. So you look at those formulas, I think you have a pretty good idea right now. Okay, this is double angle formula. So this sine x cosine x is here. So we put them together. Okay, then you get a single one function. Okay, it's going to be sine 2x squared. Okay, so you get a quarter. Then I use the above formula. Okay, change the sine 2x to cosine 2x, that's 4x. Okay, it's going to be 1 minus cosine double of 2x is 4x. Okay, great. Okay, then you solve the problem. 1/2 is just the antiderivative is x over 2. Cosine 4x is the antiderivative sine 4x, but you have to divide by 4. That's it. Great. That's what we get. Okay. Then I think the lowest power will be cosine squared, right? So let's increase the power of this. Actually, it turns out to be this is a little bit easier than the previous problem. Okay, sine cube x can be written as sine square x, because in my eyes, sine square x, cosine square x are almost the same, okay? And then sine x dx. I think if I express in this form, you know what this method you're going to use. Right. Right, you know what the method you're going to use. Substitution, okay? So you let u to be cosine x, du equals negative sine x dx, okay? But this sine is going to be 1 minus, sine square x is 1 minus cosine square x, right? So now it's going to be 1 minus u square, and negative du, okay? Wow. So it's integral polynomial. Then we know how to do it, right? U square, u to the 4th power, because I have a negative sign here, minus u square du. Okay. Then you find out it's 1/5 u to the 5th minus 1/3 u cubed plus constant, and replace u by cosine x. All right, done. Now, then you say, okay, then you can solve this problem. How about this? So there are many combinations there, right? I use and trying to solve all of it, right? This is indeed it's difficult, honestly. Okay. All right. However, if you change it to, there are many ways to try, okay? So you can change it to this. Then you get two separate integral, and you know already get this, right? But we haven't done this one. So if you know how to solve the and solve this, and you know how to solve this, you can. This is already done, right? In the previous. But so this problem is more complicated. Does not mean you cannot solve it. It just involves many steps. That's one way to do. Another way is I don't know. It's going to be you have this other method may be more difficult. Yeah, because it's square. So this also can be viewed as sine square x cosine x square. Then what? Right? Right? It's not yeah, it's possible, okay? I don't say it's not impossible. We can try this later, okay? But sine, yeah, we already figured out sine integral of sine to the 4th power. I stopped at the sine to the fifth, right? X. I did not even mention sine to sixth. Right. Well, let's try. Okay, the idea is a sine square x cubed. Right. And I'm going to cosine 2x cubed. I just want to tell you, we can solve the problem. I take the constant out. It's 1 cubed minus 3 cosine 2x plus 3 cosine squared 2x and plus cosine cubed 2x. You see? And you okay with this, probably also with this one. Okay, this is going to be 1 plus cosine 4x divided by 2, right? Yeah. The cosine cube, I think we can evaluate the cosine cube already. Okay, cosine cube. Okay, you have to use a substitution. Okay, so the only term you have a trouble is this. Then how to evaluate cosine cube? You see, I just say you can do that, but it's a little bit complicated. Cosine cube is going to be cosine squared 2x cosine 2x dx, right? Then use a substitution, right? Because this is going to be 1 minus sine squared 2x. Okay. Finally, and you can put everything back, right, step by step. So finally, u equals sine 2x and u equals 2 cosine 2x dx. Okay, so I'm going to get 1 minus u squared and half of du. Okay. So the antiderivative of u minus 1/3 u cubed. Okay, I'm going to write down the answer. U is going to sine 2x minus 1/3 sine cubed 2x plus constant. So let's go back, right? So I get cosine cubed 2x, what is given here. Then I can evaluate every term here, right? Right? So then I get a sine to the 6th power. Then I put it here. Already got sine to the 4th power. It's a giant project, right? But finally, you do get sine to the 4th power cosine squared. Okay. Right? But is there any way going around? Then you have to try this. Okay, you have to try this. Okay. So let's go over 2 important formulas. Okay. We know, yeah, cosine alpha equals cosine alpha cosine beta minus sine alpha sine beta. Okay. If there's a negative sign, I have to change it. Right? So that means if I add them together, I get the double of a cosine alpha, cosine beta. So it's going to be the sum of those two. You see, the reason I want this formula is I change the product to the sum. If I equation 2 minus equation 1, I get a double of sine alpha sine beta. Then I have to write, okay? Yeah, maybe it's better change. Yeah, that's easy to memorize. It's a similar format, only different by a negative sign. All right, So if you use this, then you can evaluate the integral. You can evaluate the integral, cosine x, cosine 2x, okay, dx. We can evaluate in a slightly different way, but if you use above formula, it'll be much easier because you can change your cosine 2x to, you can try, let's use above formula first. So it's the integral of a cosine of the difference of the two angles, x minus 2x, plus cosine x plus 2x, right? Then it's linear combination, no square, no product. So cosine negative x is just cosine x. And then cosine 3x. So the antiderivative of each function is clear. Okay, that would be sine x. That would be sine 3x divided by 3. All right, we are done. If you use above formula. Now, if you do not use above formula, some students still remember cosine 2x is going to be something different, right? It's not too bad. It's if you use a different method, then you have to decide the cosine 2x, how do you write it? We can write it as 1 minus sine squared 2x, or 2 cosine cube x square x minus 1. I think the second one as the first one is better. Why? Because the second one you have to deal with a cosine cube x, then you have to work on cosine cube x. If you use the first, this is another good choice. This is a good choice, okay? That's my experience. The reason is, okay, I got, 1/2 cosine x, don't worry about this term, minus 1/2 sine square 2x. Sine square is not 2x, sine square. Cosine x, right? Yeah, dx. See, here you can use a substitution. Okay, here you can use substitution. So the first one is the antiderivative cosine x and sine x. Don't worry about that. And then use a substitution. Then use a substitution. You let u to be sine x, right? So du equal cosine x dx. Use substitution, then you got to use square, right? Du. So the antiderivative u square is 1/3 of u cubed. Okay, so u cubed is replaced by sine squared, sine x. Then sine cube x. And then you say, well, how can I know these two answers are the same? Right? So you see that, right? I know that, okay? If it's on the, if you use a computer, just enter the numbers on the screen. The background, computation will show you this is the same, okay? Sine cube x differs from sine 3x by some constant, okay? So, sine cube x can be converted to sine 3x can be converted to sine cube x. Okay, but I'm not going to spend time on it. Okay, so those are the same, essentially the same. They express in a slightly different way. Sine x divided by 2 sine x divided by 2, this is the same. All right, sine 3x, can you change it to sine cube x? Yes or no? Let's see. Yeah, what is sine cube x? Can I change it to sine cubic, sine squared cubic x plus some constant, right? Or minus, because this is a plus here, right? Minus, right? Sounds like that, right? We have this. Okay. Let's see. I'm not sure. Okay, maybe that's a different way. Cosine x. Yeah, cosine x, sine x. Let me double check my computation here. Oh, I missed the one term. I'm sorry. I was wondering, that was it's not square here, it's 2 here. So that will be 2, right? So it's no, yeah, this is not constant. It's no 2, right? Multiply, yes. Okay, so you see, I have some sense, you know, there was a mistake. Okay, so that means I should be able to get twice of this. Yeah, when you compare those two terms, right, two solutions, right? One is 6, one over 6 times sine 3x. Other one is negative, right? So sine 3x, yeah, let's try to do that. Sine 3x, how can I change it to a single x, right? So that is going to be, I need another formula, okay? So otherwise, how can I change the sine 3x, right? All right, so here's the formula. Sine alpha plus beta is going to be sine alpha cosine beta plus cosine alpha sine beta. That's the first equation. Then if it changes the sign, you get changes its positive beta to negative beta. That's equation 1, equation 2. I think we just need a one equation, just add them together. Okay. If you do the subtraction, you do get cosine alpha sine beta, but it's essentially the same, right? So sine alpha cosine beta is going to be half of sine alpha plus sine alpha minus beta. Okay. Right. And if you do subtraction, essentially you get the same. Right? Equation 1 minus equation 2. Yes, you get a cosine alpha sine beta. The sine alpha plus beta minus sine alpha minus beta. Okay. So those are the important formulas. Okay. Okay, so let's see. We use the original equation. Okay, sine 3x is sine 2x plus x, right? So according to the above formula, it is going to be it is going to be sine 2x cosine x plus cosine 2x sine x, right? And the sine 2x is going to be 2 sine x cosine x. Then you have a cosine, cosine, so cosine square x, right? And this one, cosine 2x is 1 minus 2 sine x sine x, right? Yeah, that's right. So you multiply this out, and I change the cosine x to 1 minus sine square x. So you will get twice of sine x minus twice of sine cube x plus sine x minus 2 sine cube x. So what we get here is going to be 3 sine x minus 4 sine cube x. Well, that's a surprise to me. Okay, let's double check if anything's wrong here. Okay, so, right, sine 2x cosine x, cosine 2x sine x. Then you change it to this, okay? Then you get cosine squared minus, yeah. All right, so you can change to sine 3x to something only involves sine x. Okay, now there's still some difference here. Well, I don't see any mistake here, so there should be, you have to continue to find, yeah, you continue to find the difference. Well, they should be identical, okay? So this is, I leave it for you to investigate, okay, why they're the same answers. But anyway, you can change the cosine, sine 3x to sine x and maybe cube, okay. Now, we want to do the following type of problems, okay. I want to evaluate this integral, okay. How can I do that? There are a couple ways to do it. One is you apply the above formula directly, which is called sine alpha, right? Sine alpha cosine beta, okay? If you use this formula, and then the product becomes the sum, okay? This is a sine alpha plus beta, okay? Plus sine alpha minus beta, okay? So you will get sine 3x, sine x dx. Then you find the antiderivative of each of them. Okay, so you can get negative cosine 3x divided by 3 is negative cosine x and plus constant. Well, for this particular problem, there is a method to solve, okay? And you see, we play with those formulas, right? All right. So this is also can get 2 sine x cosine x, right? Then you immediately can see, oh, that's a cosine square x. So you can use a substitution to solve the problem. Right. Yeah, let's see. How do you do that? You end up with a different form of solution answers. Okay, so use a substitution. You let u to be cosine x, right? U equals sine x. So it's going to be 2u squared du. And that is going to be no, negative. It's a negative, yes, that's negative. Okay, so u is going to be cosine x. Okay, so you still have a question, why those two are equal? Right, why is those two are equal? Does it equal to negative 1/6 cosine 3x minus 1/2 cosine x plus another constant? And this one answer is yes. Okay. The answer is yes. Okay. So use a similar idea. You can change cosine 3x to cosine x to some expression in terms of cosine x. So these two are actually the same answer. Okay, then you get the same answer. Okay, let's take a look at the next one. Sine 2x sine 6x dx. Okay. So the only way you can solve the problem is to use the formula, change the product to the sum. Okay. If you forgot this formula, let's go back. Cosine formula, right? Yeah. We want to, what do we give it? We are given sine. Sine alpha, sine beta. It will be cosine alpha minus beta minus cosine alpha plus beta. Okay, remember this. Okay. Cosine alpha minus beta minus cosine alpha plus beta at dx. All right, so this will be cosine negative 4x, it's just 4x minus cosine 8x. And then you get the antiderivative of each term. This should be sine 4x divided by 4. This should be sine 8x divided by 8. Okay. Yeah, let's go back that we have discussed. I think you can verify this to change cosine 3x to some expression in terms of a cosine x using the formula. Okay, I can insert the material here, right? Cosine 3x is going to cosine x plus 2x, right? That'll be, remember, is cosine x cosine 2x, okay, minus sine x sine 2x, right? Do you remember this formula? Yeah. So alpha minus sine beta sine alpha sine beta. Okay. If you double check the formula I gave to you at the very time. See, when you use a cosine, okay, cosine, then you change the sign. Okay, cosine alpha plus beta will be cosine alpha cosine beta minus sine alpha sine beta. Cosine alpha minus beta, you change the sign to the positive. Okay. So yeah, let's go here, right? So so now we want to change the cosine x, right? So it's cosine x, and this will be 2 cosine square x minus 1, right? And minus sine x will be 2 sine x. cosine x, right? Then same idea, okay? So here we have 2 cosine cube x minus cosine x and minus 2. Sine square x is 1 minus cosine square x and the cosine x. So after you expand it, you have a cosine cube x and 2, that's 4 cosine cube x. And then minus 2, so it's minus 3 cosine x. Okay. So that's the relationship. Cosine 3x can be written as this. Then if both sides divide by negative 6, you end up with the same identity. So we prove that, right? So this is why this is yeah, we put the question mark here, and that's the proof. Okay. So different students maybe have the different approaches to solve the same problem. So the answer, the final expression of the answer will be different, right? Especially for the problems in this section, because sine, cosine are not new functions. They are really internal related. Okay, that's why you can express the same function in different form. Okay. Yeah, if we're trying to compute sine 3x, it will be 4 cosine cube x minus 3 cosine x, you see? And if we're trying to compute the sine 3x, then it will be expressed in terms of sine x and sine cube x. I think I have discussed enough problems. What you need to do is you look at my notes, okay, and you try to cover the solution and then redo it by yourself. If you can complete all of them, you probably don't need to do the homework, right? Yeah. So those are the problems involve all the techniques, and we need. Okay. So this is those are the formulas from Math 154, which is called pre-calculus. Okay, and you will see that even you had trouble to understand all the formulas in that course. Right now, you have to refresh your memory, and then you get all those, use all the formulas to simplify functions or to evaluate integrals. So after this practice, you will fully understand, okay, those formulas. If you go back to take a test, Math 154, you can do better. Okay. I think online courses, the most important thing, you finish your homework in time, okay? And I also do my best to post my recorded lectures, so you can watch it again if you have a time, okay? And if you have questions, you can come to the class, and ask me at the very beginning of the class, okay, like what we did. Okay? So we can, I can discuss. Sometimes I do not have enough time if there's a quiz time, okay? Usually if there's no quiz, I should have enough time to cover the whole section, okay? And we can also discuss some problems you want to discuss, in the class, okay? And let me repeat again, and when you submit your quiz, name your file, right, as a last name dot the quiz number and dot PDF file, okay? If you're able to save as PDF file and send it to me. You can send it to Canvas, or you can send it to me directly. A couple of students still send me by Canvas. And that's okay. I mean, just one more step for me to